Hi there, welcome back to Introducing Algebra. This is part 2, and I wonder how you got on with the problems I left you, the puzzles. Did you write a mathematical sentence or work out the answer without one? The mathematical sentence is going to be important later on as algebra develops. So I'm going to let the mystery number be n in these sentences now. So let the number be n. I think of a number, double it, that's 2n, add 10, and the answer is 22. What did I have before I added that last 10? So let's take it away. After doubling the number, we would have had 22 take 10, which was 12. So what was the number? Let's reverse that doubling by dividing by 2, and the number would have been 6. Problem solved. Let's do number 2 now. I think of a number, I triple it. That's timesing by 3. I add 5, and my answer is 11. So, what was the value after I tripled the number? Let's take that last 5 away. So 3n would have been 11 take 5. It would have been the value 6. So let's reverse that tripling. Let's divide by 3. And my mystery number was 6 divided by 3 is 2. So problem solved. Let's have a look at number 3 here. I think of a number, double it, so that's 2 times n. I add 10, take away 6, and the answer is 16. Let's try to reverse some of those steps. Before we took away the 6, let's see what it would have been. Let's add the 6 back on again. Would have been the number 16 plus 6, number 22. And then if we took away 10, after doubling, the number would have been 22 take 10 is 12. So 2n is 12. Let's reverse that doubling by dividing by 2. So the number again is 6 here. It works very nicely. Let's have a look at the last one down here. Think of a number, I triple it, so that's 3 times n, add 12, take away 3, and then I'm going to divide it all by 2, so this is a tricky step here, divide it all by 2, and the answer is 9. We could also make this a little bit neater, looking at this top line here, because this is 3n. If we added 12 and took 3, effectively what we're doing is only adding 9, isn't it? Because 12 take 3 is 9. So let's perhaps write it more neatly like this. Now the last thing that was done was division by 2, so let's reverse that back again. It's times by 2, and we'll be back at 3n plus 9 equals timesing 9 by 2 is 18. Let's go backwards further. Let's take away the 9. So we're back to triple the number. And then take it from 18. 18 take 9 is 9. Reversing the tripling by dividing by 3. N would have been 9 divided by 3, which is 3. So the mathematical sentences help us guide our way through the solution. And did we get them right down here? Yes. Here are our numbers. 6, 2, 6, and 3. Very good. I wonder if you'd like to think about our process a little bit differently. Imagine it's your birthday. I'm going to give you a mystery present. Call the mystery present X. So the first thing I'm going to do is I'm going to put the mystery present in a box. There it is. X, the mystery present, is in a box. Then I'm going to wrap the box up. So let's put the steps here. I put your present in a box. I put wrapping around it, and then I'm going to put some ribbon around the outside. Now let's just go back here. So we're going to have ribbon around the outside. So we've got ribbon. Do you want your present? What do you have to do? Well, you have to remove the ribbon. So we start at the bottom and work backwards. We need to remove the ribbon, then remove the wrapping, and then remove the box. This gives you some sort of idea of how we can solve mathematical equations or sentences by basically working backwards from the last step done and retracing our steps. So in the next presentation, what I'd like to do is to show you how not only simple number puzzles can be done in this way, but that you can solve some practical problems as well. So I welcome you to Introducing Algebra Part 3 in the next presentation. See you then.